poles of a rational function. Polynomials are continuous functions. And we see examples of rational functions that have vertical asymptote, which is the only type we will deal with. Is it possible to have no vertical asymptote? The answer is yes, but we're not going to deal with that. The vertical asymptotes form a type of discontinuity in the function, a break in the function. But another type of break in the function is in the form of a hole. Holes occur when we have a common factor between numerator and denominator. Okay, that's when it occurs. For example, what does the graph of Rx, x plus 1, x plus 1 look like? Well, let's kind of think about this for a second. X plus 1 over x plus 1. I mean, isn't that the same thing? So isn't that just equal to 1? Right? But we also recognize that, hey, wait a minute, the denominator cannot be 1. So the domain of this, if I were to look at this and say, well, the domain, the denominator cannot be a 0. So it looks like -1 makes the denominator 0. So the domain of this is negative infinity to -1, union -1 to infinity. In other words, this thing cannot be equal to 1. But then what does, again, this look like? Here's what it looks like. And this makes sense. If I, for example, if I enter a 4 here, right, both places, I get 5 divided by 5, that is 1. 6, 7 divided by 7 is 1. 3, 4 divided by 4 is 1. So it looks like no matter what I enter, just about, I'm going to get the following. Just 1, 1, 1, 1, 1. However, I cannot enter -1. So what happens here? What at -1? For example, if I enter 0, so I got 1 divided by 1 is 1. So that's not a problem, but what's happening right here at -1? If I enter -1, I get the case 0 over 0. And is that equal to 1? The answer is no, it's not. But if you were to graph this, here's what would happen. Imagine getting infinitesimally close to -1, -0.9999, -0.999. Each time you entered here, you would still get a 1 coming out. So no matter how close I got, I would get a 1, right? So if I enter, for example, x equals not -1, but 0, -0.99999 plus 1 over, same thing, right? -0.9999 plus 1, the answer is 1. So I can get as close as 1, but as soon as I make it -1, the whole thing blows up. So what happens is, I'm enlarging this to make it more exaggerated. There's literally a hole. So what does this look like? It looks like 1, except there's a hole at 1. So what happens when you have a common factor between the numerator and the denominator? There's a hole at that position, whether where you think of this as having a 0 or having a vertical asymptote. It has neither. There's literally a little hole. For example, what does the graph of Rx, x plus 2, f1 look like? Okay, so notice we know now that x cannot be equal to -1 after all. That's what we just said about this. That thing blows up. But if I were to cancel, so let's just do this, x plus 2, and let's just do something you would have done in earlier math class, like say, please simplify this. And then you go, okay, I'll simplify by just and then I get x plus 2. But again, to be fully correct, the x cannot be equal to -1. So if I were to graph this, y equals x plus 2, what do I recognize? This is just the 45-degree line, x equals y, but shifted up 2 units upward. I'm lifting up. So other than that, this has a rise and run over 1. So run 1, rise 1. Right? And then on the other side, run down 1 to the left. So you get this picture right here. Okay. But we said that x cannot be equal to -1. So what happens at this point? Well, notice, oh, actually, I didn't make this to scale, unfortunately. Yeah, to make this better, let me just, I'm jumping the gun here. Let's make this 2. Let's make this a little better looking. Put 2 here, and it's a run 1, up 1, down 1, dun. Yep. So down 1, up 1, so it should be -2 right here. Great. Okay, that's a little better. Right, because I have -2, enter -2 here, -2 plus 2 is 0. So they're right there. But what happens at -1? Well, if I enter -1 now into this, what is the value? 1. So entering -1 into this, -1, -1 plus 2 is 1. So I get that point right there. But what happens if I enter it into this one, which is the correct one, the original? Well, then I have a hole. So where is the hole at? Well, it's right here. There's going to be a hole, literally a hole at 1, -1, 1. So there's a hole at -1, comma 1. That's the location of a hole. So how do you determine a hole? Well, when you have a common factor, what you can do is determine the number that this can't be. We determine that it cannot be -1. That we cancel or simplify this, and then we stick in this value inside of this to determine the actual location of the hole. So what's happening is, remember, this over this is essentially 1, except at the point where it blows up. So what's happening is having the same number, they're canceling each other out because it's just 1 and leaving this as is. So the graph just looks like the factor that's not being replicated. And then when we cancel, all of a sudden, we can determine where literally the hole is located. So for example, what does a graph of this one look like? Again, notice we have the same situation. We have that x cannot be -1. Also, we have this little problem here that x cannot be -2 either. Okay, but let's think of it this way. I'm going to cancel both of these, and what do I get? So now I have this other function. Once I cancel these two, I get x plus 2. So remember, this is just a transformed version of this one, but it's moved 2 units to the left. So we know what this looked like. That's that. This is this picture right here. But what's happening is we're moving this now 2 units to the left. So now, if I were to draw a better picture, -1, -2, the vertical asymptote has now, well, it used to be at 0, so before, the vertical asymptote used to be at 0. Now we're moving everything 2 units to the left. So the vertical asymptote now is at x equals -2. Right, we moved it 2 to the left. So now there's a vertical asymptote right here. Other than that, the graph looks exactly the same. So for example, if I go 1 to the right, 1 up, this picture, and just like before, 1 to the left, and down 1, you get that position right there. Okay, so 1, 1, 1, -1. So the graph of this looks like this. Except there is now a hole, and it happens when x becomes -1. So wait a minute, so what does this look like if it becomes -1? So now we go back to our now cleaned up version and to the -1. And what I get here is -1 plus 2 is 1. I get 1. So at -1, 1 there is a hole, so -1, 1. So right where I marked this, there's actually nothing there. It is literally a little hole right at that position. That's what's happening. So when the factors replicate, there are holes there. And the hole happens where this becomes a 0. Whether you look at just the numerator or the denominator, doesn't really matter, just look at one of them. And that is where nothing can happen. You simplify it by getting rid of this, and then you have your brand new function. And then if you want to figure out where the hole is, plug this location in here, and that will tell you the coordinates. So again, the hole in this case is occurring at, again, here's my input, -1, and when I entered that, I got 1. And if you want, just go to Desmos and play with yourself. Play with this, these things. Play around. Just put here one value, play another one value, and then repeat and put anything else, and you'll see that you get a picture. And then type the RX, for example. If you were to type this into Desmos, just enter -1. Once you have this, first enter this whole thing, and then in the middle line type A, and you'll see that all it says is undefined. It will produce nothing back out.